Hello students and welcome to part 3, last part na no, ng week 10 discussion of LAP 7 which is again force due to magnetic fields and sources of magnetic fields. Now that we know the things about magnets, their types, what they do, and then magnetic fields and some stuff about it, let's have some application of magnetism. And the first one is MRI. No? So dalawa lang yung ipapakita ko. No? MRI stands for magnetic resonance imaging. Inside the MRI system is the magnet. Of course, dapat may magnet, permanent magnet. These powerful magnets, hindi lang siya isa, are up to 30,000 times stronger than the Earth's magnetic field. Alam naman natin previously na sobrang liit lang ng magnetic field ng Earth. The strength of the magnet is rated using, of course, Tesla as a unit and not Gauss. So, naka-SI unit ng ating MRI. Tapos may tinatawag tayong fringe field, which is the region surrounding the magnet and exhibit a magnetic field strength. Okay? Ayan siya dito, ihiga yung patient, and then there's a scanner, there's radio frequency coils and stuff, and magnets. No? So, paano ba to gumagana? Usually, ginagamit natin ang MRI sa hospital, no? Ayan, syempre sa hospital. Ginagamit siya sa hospital. Tapos, yung purpose niya is just like X-ray, but in X-ray kasi if you have metals inside your body, you can still undergo X-ray. But if you have metals inside your body, you cannot undergo MRI. So there are 3 people actually who cannot undergo MRI. Number 1, the people with metals inside their bodies. Pwede yung mga ginamitan ng metal kasi naputulan sila ng buto or something. Hindi yun pwede. Tapos yung mga may metallic pacemakers, yung mga na-operahan sa heart dati, hindi sila pwede, no? At syempre, bago ka mag-undergo ng MRI, mahubarin mo lahat ng metals sa katawan mo. Kasi nga, yung magnets na ginagamit for MRI is very, 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 very strong. Okay? So, yon. Nauna na yon. Tapos, pangalawa is yung mga pregnant women because the baby inside cannot take, masyado pa silang vulnerable for a magnetic field this strong, no? And then, yung mga tao na may tattoo. Okay? Kasi sabi nila, or hindi, it is known that the stuff or the ink used in carving, drawing the tattoo, it has iron in it and it can be attracted by the MRI. Kaya hindi daw sila pwede. Hindi ko lang sure kung meron ng MRI ngayon kasi yung knowledge na nabasa ko, no? Na kung pwede na yung mga may tattoo. Kasi hindi ako sure kung may development na sa mga ink ng tattoos na wala ng iron component, no? Ayan. So the MRI is used most commonly to visualize the structure and function of the body. So may color coding stuff sila kaya mas okay siya kesa sa X-ray. Kasi si X-ray usually sa buto lang siya eh. But MRI can also, depending, hindi kasi ako marunong bumasa ng MRI, no? So may color coding yon. Tapos base sa colors na kaya may radio frequency. Kasi yung radio frequency ay yung na transform into images, no? Ayan. Mag-visualize paano nagpa-function yung brain mo, paano nagpa-function yung internal organs mo, and stuff like that. So yun, mas okay si MRI. It provides detailed, ayan, images of the body in any plane. Hindi lang siya sa buto. And then, it works this way. Yung tissues natin, they are actually made of protons, of course, and electrons. But the MRI is more concerned with the protons, and they are positive electrical charges spinning around its own axis, just like electrons, no? And this actually, katulad din ng electron, ano din siya, may magnetic spin din siya, no? And then these protons are considered to be analogous to small bar magnets. So may north and south poles din sila. So the interaction between the magnet used in the MRI and the protons, which are considered to be small bar magnets, is the one that produces radio frequency, which is then transformed into images. Ayan. The strong magnet aligns the protons, which creates the image or is transformed, gives a signal that produces the image. Ayan. And then the second application is the Maglev train. Maglev is shortened word for magnetic levitation trains. Maglev trains use superconducting magnets. Nakita naman natin dun sa ating uh, previous video na ang superconducting magnets ay may lakas na 30 Tesla. Imaginein mo sobrang lakas nun kasi 2.5 Tesla lang yung ordinaryong magnet na nagagamit natin. Imaginein mo yung 30 Tesla. Ang laki nun, no? So, yan yung ginagamit nila for these trains. In the track pala, and syempre dun din sa train mismo. And on the underside of the train to float above the track. Kaya siya magnetic levitation. Syempre magka-opposite yun kaya nagle-levitate. Kasi kung hindi yan magka-opposite, hindi siya, mag-a-attract siya, di ba? So yung nakakabit sa train, yung poles ng magnets noon ay opposite ng poles, opposite tuloy, same pala ng poles ng magnets na nandun naman sa ating track. Maglev trains use magnetic repulsion and they can travel very fast up to 480 kilometers per hour. And one famous example of maglev train is the bullet train in Japan. Kaya sila mabilis kasi nadi-diminish yung effect of friction. Kasi di ba yung trend dito sa Philippines, hindi naman hindi magnets ang gamit, of course, no? So there is friction between the rail, and then there is also the rail track, and then there is also that is because of the interaction din dun sa wheel. So pinapabagal siya ng friction dito, nade-diminish yung effect of friction, kaya mas mabilis siya. And then, ayan, hindi ko alam kung aabot tayo dito, papagawin ko kayo ng graphic organizer to summarize everything that is been discussed in the lesson. I know you already conducted or created your own graphic organizers in other subjects, so alam ko maning-maning na to, no? Sana. And after that, if the electron is the smallest existing magnet, the biggest existing magnet here on Earth is the Earth itself. And it has, of course, the North Pole and the South Pole. But notice that the magnet, kung may bar magnet sa loob ng Earth, of course, walang ganyan talaga, no? Representation lang yan, to tell us that in the North Geographic Pole or in the geographic North Pole, dun sa North Pole, ang nakalagay doon is the South Magnetic Pole of the Earth. So magkaiba yung magnetic pole ng Earth sa geographic pole. Yung geographic North Pole natin, of course, nasa may bandang taas, doon nakatira si Santa Claus. Charot lang, syempre, hindi tayo sure doon, no? Ayan. And doon ay makikita natin yung South Magnetic Pole. Tapos sa geographic South Pole naman natin, doon natin makikita yung North Magnetic Pole ng Earth. So bakit ganyan? Bakit magkabaliktad yung geographic North Pole at saka yung magnetic poles natin? Okay? Kasi nga, yung compass natin, actually, kaya sa tumuturo papuntang north is dahil it's north, hindi. Kaya siya tumuturo papuntang south kasi its magnet is, ano yung sinasabi ko? Kaya siya tumuturo ulit. Nalito ako sa dalawang north at south, no? Kaya siya tumuturo sa north geographic pole kasi sinisik niya yung south magnetic pole, 'di ba? Kasi nga 'di ba opposite poles attract. So, kaya tumuturo papuntang North Pole yung North Needle or yung needle mismo ng ating compass kasi sinisik niya yung South Magnetic Pole. Okay? And yung South Magnetic Pole na yun happen to be in the North Pole. Baliktad siya kasi yung needle natin tumuturo papuntang north ng north ng Earth, okay? Pero ang sinisik niya is yung South Pole ng magnet. So kung North Pole yung needle, yung South syempre yung kanyang isisik. Kaya nasabi ng mga scientists na South Magnetic Pole yung nasa North Geographic Pole. Yan, hinahanap niya ng compass needle yung South Magnetic kasi opposite poles attract. Ina-attract ng South Magnetic Pole yung needle ng compass. Kaya tumuturo siya sa North Geographic. Okay? Sana malinaw yun, no? Ayan. Now, saan ba nanggagaling yung magnetic field ng ating Earth? It is said to be, or it is agreed upon, that the Earth's magnetic field is produced by the liquid part of, excuse me, the core, okay? This cannot be large masses of permanently magnetized materials since the high temperatures of the core prevent materials from retaining permanent magnetization. So, hindi siya nanggagaling dun sa solid, kundi dun sa liquid kasi yung liquid part is nagmo-move and that movement creates electric currents. And later on, we will discuss that electric currents actually produces magnetic fields. Katulad nga sa electromagnet, di ba? Kung wala namang electric current, ay hindi magiging magnetic yung ating nail na ikinabit natin doon sa battery. Okay, so kaya siya sa liquid part ng ating core, meaning dun sa outer core ng galing or yun yung source ng magnetic field ng Earth. So walang solid na bar magnet sa loob ng Earth. Kahit hukayin mo pa yan, wala, no? Okay? Dun lang siya sa outer core, liquid outer core. At hindi rin siya dun sa inner core kasi hindi hindi magnet yung solid na to sa loob ng core natin. Ayan. Hindi siya yung akala mo spherical magnet, hindi siya ganun, no? Ayan. Metal siya doon. And actually, the Earth's magnetic field reverses its poles. So as of now, the South Magnetic Pole is in the North Pole, and the North Magnetic Pole is in the South Pole. Pero may moments in history na nagbaliktad yon. The direction of the Earth's magnetic field reverses every few million years. Evidence of these reversals are found in basalts resulting from volcanic activities. The origin of the reversal is not yet understood. So, dati, because of World War II, siyempre may mga ispi-ispiya, may mga technology na nauso para makadetect ng mga submarine, no? Kasi, siyempre, kapag sa sky ka nag-spy, eh kitang-kita ng kalaban yon. So, yung ibang mga countries, naisipan nila, tara, mag-submarine na lang tayo pag mag-ispiya tayo. Kaso, syempre, matatalino din naman yung mga kalaban. So nakaisip sila na paano natin i-detect ang mga submarine. At syempre mga submarine are made out of metals. So they come up with metal detectors. At syempre, ano ba ang best way para makadetect ng metals? Magnets, 'di ba? So, mayroon silang ginamit na what we call it, magnetometer, basta something meter, tapos may magnet, no? Nakalimutan ko yung pangalan, search nyo na lang, no? Pang-measure ng direction ng magnetic field at syempre pang-detect ng magnetic field, no? Ayan, at pag-detect din ng metals. So instead of just looking at or finding submarines, they were also able to observe that in the seafloor, the magnetic fields, the magnetic moments of the seafloor, certain have certain orientations that changes. Ganito yung changes niya, no? Ito yung pinaka-recent, letter C. Ito yung pinaka ah, late, no? So, napansin nila na itong mga orange strips, they are normal magnetic poles. Meaning, katulad sila nung magnetic orientation natin ngayon. Lahat nakaturo, yung mga magnetic moments nila nakaturo sa North Pole. Yung North Pole nung ah, magnetic moments nila nakaturo sa south kasi south seeking sa south, no? Nakaturo sa south ng earth. So i-drawing ko, no, para mas malinaw sa atin. So itong mga orange-orange, 'di ba ang orientation nga ng earth ay nandito yung south pole, tapos nandito yung north pole, magnetic. Tapos, napansin nila, yung mga orange-orange na yan, yung magnetic domains nila, or moments, magnetic moments, pag ganito yung orientation. Remember natin, yung sa magnetic moments, yung arrow, ayan ay north. Tapos yung tail, yan ay south. So, ganyan yung orientation, which is in agreement with what should be observed right now. Dapat magkabaliktad kasi nga maa-attract dapat noong south seeking pole natin ng south magnetic pole natin yung north poles ng magnetic moments ng particles doon sa seafloor. Tapos na-observe nila na hindi lahat ng parts ng seafloor ganito yung behavior. May mga arrangements using the magnetometer na ang itsura ay paganito. Magkatapat yung south, syempre na-fossilize na yun, no? Tsaka yung north. Ayan. Okay? Which tells us, ito yun yung mga white na yan, which tells us that as time goes by, the Earth's magnetic field actually reverses. Umiikot siya. And hindi pa alam kung paano nangyari, bakit nangyayari, tuwing kailan nangyayari yung ganitong movement. Pero hindi to yung biglaan kasi baka isipin nyo biglaan siya na after a million years may isang araw na bigla na lang nasa North Pole, nasa North Geographic Pole na ulit yung North Magnetic Pole natin. Actually, if you search in the internet, the magnetic pole of the Earth actually slightly moved. So, ibig sabihin, kung ito yung Earth natin, tapos initially nakaganto yung polarity ng magnetic field natin, unti-unti siyang gumagalaw. So, galing dito, unti-unti siyang iikot. Hanggang sa totally bumaliktad yung orientation nung magnetic poles. Okay? So, medyo slight na nag-move siya ng kaunti dito. Ayan. Just recently, nabasa ko lang yun. Nakalimutan ko lang kung ano yung degree ng pagkaka-move niya. Pero nag-move na siya, no? So, ganun yung nangyari. Ito mga white, mga naka-opposite yan. So, nung unang panahon, unang-una, ito yung ocean ridge. Di ba dyan lumalabas yung magma galing sa mantle. Ayan. So, same yan ang polarity ng Earth. Tapos ito, magre-reverse. Siyempre, after some time, maglalabas ng magma yung ating mid-ocean ridge. Okay? So mag-spread out. Merong galing dun sa dati pa, ito yon. Ito yung galing dun sa ito. Tapos may mabubuo ulit. Tapos ito magsusolidify na. Okay? So isa sa mga, itong magnetic reversal, isa sa mga evidence na ginamit for seafloors spreading theory. Kaya nagmo-move yung mga continents emerlu, no, sa earth science ninyo. Isa siya sa mga naging evidence yung magnetic reversals. Kasi ibig sabihin, after sometimes hindi na nga magkakaedad yung mga basalt dun sa seafloor, magkakaiba pa yung ano nila, orientations ng magnetic field, magnetic field moments, no? Magnetic moments. Ayan. Okay, ayan. So, yan lang. Yan lang for week 10 discussion of LAP number 7, and see you next week for the same topic, but it's going to be week 11 discussion. And kung mapapansin niyo, wala tayong computation for this week kasi lahat ng computation would be discussed next week. Thank you for listening and see you next week.